So hello everybody, and also from my side, thank you very much for joining this session, and of course thank you also to the organizer for inviting me, giving this talk. Before we start, maybe with the content, just a few words about myself, if you don't know who I am and what I do. My name is ChrisAntognini. I work for a company called Trivadis, which is a Swiss-based company, but we have also offices in Germany, Austria, Denmark, and the newest one in Bucharest. What I do on my, let's say, daily basis is I deal with database engine most of the time. So I'm very keen about data and what you do with that data. I'm also author of this book that was published a long time ago, 2008, for Press. Then I updated it 6 years later in 2014. And now since 6 years are passed again, I'm working on a third edition. No idea when and whether it will really be published at some point, but I hope that maybe by the end of the year I have it. Okay. Otherwise, I am an Oracle ACE director and an Oracle an Optable network member. About the content of the presentation, first of all, maybe why I decided to take this topic is not something new. So if you are already up to date with all the latest technology in Oracle database, there is basically nothing new here. The initial slides of this talk, I wrote them 8 years ago and just gave them a quick, small update last year. But at the end, I decided to give again this presentation simply because I also noticed that some people that work with Oracle didn't get correctly some of the details about cursor and what they are and when you can reuse them and stuff like that. And that's the reason why I decided just to give this talk a couple of times again. So we will talk about cursor, where they are stored, what is a parent, a child cursor. We'll talk, of course, about bind variables, and at the end also have a look to what adaptive cursor sharing is. Okay, let's start from the beginning. What is a cursor? In general, a cursor and all the structure that are associated with it give you access to some data which is available in your database server. Okay, and so a cursor is basically created when you want to execute something, specifically when you execute a parse call. So you have maybe a query, you parse it, and the result, more or less, of this parse call should be a cursor and the associated structure that gives you access to the result set of the query. Okay, but actually, what is a cursor? If you want a definition, and the definition will be one sentence. My definition would be: it is a handle to a private SQL area with an associated shared SQL area. That means if you are the client, you store somewhere in your memory a handle, which is basically a pointer to, or a structure that gives you, by a pointer, access to another structure. So the handle points to the private SQL area, which is in the server process. So at one specific time, one server process is used only by one client. So the handle gives you access to this private SQL area. And in turn, the private SQL area gives you access to the shared SQL area, which is the part which is stored in the SGA. And since it's stored in the SGA, it's the part which is shared from potentially many server processes. So as you can see, you have one pointer basically on the handle, on the client, that points to a private piece of memory on the server that also points to a shared memory on also on the server. that is basically a cursor. So let's discuss a bit more in detail what is in the private SQL area and in the shared SQL area. So in the private SQL area, basically, as the name implies, as I said before, it's private to one specific session. Okay, and so you find session-specific information. For example, if you have a query that contains bind variables, okay, the value of these bind variables is stored there because they have to be stored somewhere. Or if you executed a cursor, basically the execution state of that cursor is also stored there. Because of course, if several sessions execute basically the same operation at the same time, there is a shared part that can be reused by every one of these sessions, but of course, every session has its own state information. And since this part is private, okay, it's really specific to one session, it's also stored in the user global area of the session. So it's not shared among anyone on the server. From the other side, what does the shared SQL area contain? Basically, are all the structure that can be shared, as the name said. And basically, you can think about the parse tree associated to the SQL statement, the execution plan associated to it. Of course, if it exists, there are also statements without execution plan. And all the associated stuff that goes with it. Okay, and this one is shared. That means, again, it can be used by many sessions at the same time. In practice, I will say when we say cursor, we don't necessarily mean only the handle on the client, but we are using it loosely to speak about the handle, the private, and the shared SQL area. So if I say cursor, usually I think about all the structure which are associated to it, not only to the handle itself. Okay. Now, in the shared SQL area, we have two additional, let's say, structure that have to be described. They are the so-called parent cursor and child cursor. So this is the next topic I would like to cover. What is a parent, what is a child, and what they contain? What's the difference between them, and why Oracle at the end introduced these two structure. Let's start by the parent cursor. So the parent cursor, I would say the key information stored into it is the SQL statement on which it is based. Of course, it contains other stuff, but as a picture, as a mental picture, you can think about parent cursor is the statement associated to the cursor. So at the end, the text that is parsed by the engine to be able to execute the statement. Okay. Of course, the idea is that it can be shared. Okay, and what is important to see is when several SQL statements can share it. Basically, is when their text is exactly the same. If you have two SQL statements and the text associated to them is exactly the same, okay, then you can share a parent cursor. Okay, if it's not the same, in general, you cannot share a parent cursor. And based on that, let's have a look to a first demo. Just create a small table with 1,000 rows. Just create stats, flush the share pool, and make sure that cursor sharing is correctly set. Then I execute 5 times, we can say, the same query, because if you check the text of the query, it's basically the same. Here is uppercase, it's lowercase, but what the query does is, again, exactly the same. Here I put some blanks between them. Okay, here I put a 0 at the beginning of this value. But basically, every one of these query returns exactly the same value if we execute it. And of course, the content of the database doesn't change between the different executions. Okay, so based on what I said before, since parent cursor can be shared only when the text is exactly the same, what we can expect in this situation is that we have 4 parent cursor. One, it's the only text that was executed twice. Okay, it's this one. It was executed 2 times. And the other 3 were executed only 1 time. Okay, because again, to share a parent cursor, the text must be exactly the same. Notice that you can see where which parent cursor exists by querying with $SQL area. And basically the identifier that you can use with this view is the SQL ID. At the end, the SQL ID is nothing else like a hash value of the text. So Oracle has a function that gives as input the text and provides as output this hash value, which is called SQL ID. So if you know the SQL ID, you know basically which SQL statement you are referring to. Also interesting to point out is that the SQL ID doesn't change between databases, between versions. So if you started working on I don't know, on Windows with 11.2 and then you upgrade and migrate to Linux 19, your SQL ID for the same SQL statement will be exactly the same. So in tools like AWR or stuff like that, or in Enterprise Manager, I mean, you can always find the result of a correct mapping between SQL ID and the text associated to it and all the stats and so on. Okay, there is one only exception when 2 statements which are not exactly the same that can share the same parent cursor is when cursor sharing is set to false. Okay, and if I set cursor sharing to false, I say to Oracle, replace all values, all literal values, like in this case 1, 2, 3, 4, with a bind variable. And so what happens is that statements that are a bit different from a client point of view could be treated in the same way by the database server. So let's have a look to an example. I execute here, as you can see, 3 times the same query with just a different literal value. Okay, then 1 time is completely written in lowercase, so that's a completely different statement. And if I check which parent cursor exists, you can see we have 3 times the one with uppercase and 1 time the one with lowercase. And here, of course, you see that Oracle replaced, because of cursor sharing, the literal value with a bind variable. Okay, that's a way to increase, let's say, the kind of the chances to share more cursors. Okay, but in general, I would say cursor sharing, it's kind of a workaround for applications that weren't correctly implemented. So it's more, or it's better to use bind variable where sensible in the first place. Okay, so that's about parent cursor. It's all about more or less the text of the SQL statement. And as you have seen, in case cursor sharing is not set to exact, the default value, there is this exception with literals. As I show you in the demo, if you are looking for parent cursor, select with $SQL error. That's where the parent cursor are to be seen. And the SQL ID is the column that identifies the parent cursor in that view. Now that you have seen what the parent cursor are, let's have a look to the child cursors. So what are the child cursor? Basically, the key information, again, there are a lot of stuff stored into them, but the key information you have to know it's stored there is basically the execution plan, which is used to execute the statement, and the execution environment related to it. And even though usually we are more kind of aware of the execution plan part, which is critical, of course, for the execution, also the execution environment is very important because even though 2 applications or 2 clients execute the same query, they might execute it in different environments. That could be a different NLS environment, or they set some optimizer initialization parameter at the session level, and so on. So all this stuff makes the environment. So to be able to share the child cursor, you have to have, there are two basic conditions. The parent cursor must be the same, okay? So at the end, you need the same text, and the execution environment must be compatible, okay? So everything which is used by the database engine to execute the statement must be exactly the same. Because at the end, the goal is that if you re-execute the query with two different environments, if they don't lead to the same output, then of course you cannot share parts of it. But if these two pieces or these two conditions are met, you can share a child cursor. Also in this case, let's have a look to a quick example. Okay, let's take this one. Also in this case, I just create a small table with a minimal amount of data. And what I show here is basically that, let me scroll back, that I execute the same statement, or the same query in this case, but with different optimizer modes. As we have seen before, since the text of this query is exactly the same for every execution, I will get the same parent cursor, okay, because text is the same. But since the execution environment is different, you can see every execution has a different optimizer mode. I also use the no longer supported rule, choose, and stuff like that. Then if I look in the library cache, and now since I'm interested in the child cursor, I have to select $SQL. $SQL area is for the parent cursor, $SQL for the child cursor. And now what I find is that, of course, the SQL ID is exactly the same for every execution, for every child cursor, because they have the same text. I have in this case 4 child cursors. As you can see, there is an optimizer mode column in $SQL. You can see which optimizer mode was used to parse the statement. As you can see, we have the 4 specified before, but what is a bit kind of strange is that we have only one first row. If I scroll back, you can see that I used the old first row value, but also first row 1000, first row 110. Okay, so even though the optimizer mode was different, somehow here Oracle shares the same child cursor. In my opinion, kind of bug, but I mean, it's the way it works. First, even though there are 5 first rows kind of optimizers, if you want, because every one of them can generate a different plan, Oracle decide to share the same child cursor with every one of these execution. In this case, as you can see, the plan hash value is exactly the same. That means that every one of these execution used the same plan. This is a very important point because sometimes also I see people thinking that Oracle creates a new child if a new plan is necessary, but it's the other way around. It checks the environment, if necessary, creates a new child, then there is a plan associated to it. It could be the same plan or could be a different plan. It doesn't matter. But since from the moment that the environment cannot be shared, then Oracle has to create a new child and then generate a new plan for it. And in the execution column, we can see this child was executed 5 times for the first 5 optimizer modes that I mentioned before. Again, strange, in my opinion, not really correct, but that's the way it works. Now, if you have number of child cursor and you want to know why Oracle had to create them, so which part of the environment is not compatible, there is a view which is called $SQL shared cursor that gives you access to a number of, they're not really readable. These are a number of columns, basically flags. You see only the first, of course, only the first letter associated to each column. But you can imagine that each column here, each flag is a reason why the child cursor cannot be shared. And most of them are set to no. It means that's not the reason you're looking for, but there will be one or several of them that will be set to yes. And at this moment, you can note that, okay, here I'm looking at the child number 1. It means that when the client parsed the statement, the database engine was not able to share cursor number 0 because of this reason, which is here not really visible, but if we select only this column, I know of course which one it is, then you will see, it's the optimizer mode mismatch. So you immediately know in this case. Of course, this is a very simple case. Sometimes it's a bit tricky to understand what's really the problem. But the point is, if you see several child cursors and you don't know why Oracle created them, then you can start checking this view. In this view, there is also kind of XML column that provides a bit more information about the problem. If you use some, in this case, some XML functionality in Oracle, what you can extract from there in this specific case is that the reason is that there is an optimizer mismatch. The optimizer mode of the cursor that already existed was all row, and the optimizer row and the optimizer mode that the application tried to use was first row. So you can get a bit more information based on this output. Let me just change setting the screen a bit, the font a bit smaller, because I see. Okay. So there are ways to know why the statement cannot be shared. But the important part here is to know child cursor have an associated execution environment. If it's not compatible, they cannot be shared. Child cursor can be seen in the $SQL. And in general, to identify them, you use the SQL ID and the child number, simply because the SQL ID identifies the parent cursor, and the child number is simply a sequential integer that is increased after creating every child cursor for a given parent. Okay. And if you have a number of child cursors and you want to know why, check with $SQL share cursor. Now, let me go back to the previous sentence. When I say in general, SQL ID and child number can be used to identify a child cursor. I say in general because it's not strictly true. Because what you have to imagine is that a parent cursor can have a limited number of children, and the number depends on the version. We will see in a moment, but the point is it's not unlimited. So at some point in time, when you have reached the maximum number of child cursors, the engine has to do something to cope with this case. And what they do is to simply create a new parent cursor that will have the same SQL ID, but it's a different one. It's stored somewhere else in memory. Okay, and that's the reason why in some, let's call them extreme case, you can have several parent cursors with the same SQL ID, which are in the library cache. Okay. Now, let's talk about the limit. I said that there is a limit about the number of child cursor of a given parent. And basically, this feature, or it's not really the feature, but the ability to configure that feature was added by the enhancement that you see in the title of this slide. So when you will receive the PDF, you will be able to click on the link and see the note in Moz. But the point that Oracle at some point said, okay, let's add an undocumented parameter to configure this limit. And it was added a decade ago or so it's not something new. The name of the undocumented parameter is cursor obsolete threshold. Here you see the default values since 11.203. At the time it was added. So you have 100. So only few, if you want, children could be associated to a parent. Since 11.204, it was from 11.204 up to 12.102, it was 1,024. Okay, and starting with 12.2, it was increased to 8,192. Okay, so that's the maximum number of child cursors that a parent can have. And as I mentioned before, if the maximum is reached, they have to create a new parent and just reuse that one. In such a case, if you want to, if you have several parameters, the same SQL ID, if you want to identify the parent cursor, the only column you can use at that moment is the address, because that's really the memory address where this thing is stored, so it will be unique. Of course, the SQL ID is much better because it doesn't change from between databases and so on. As I said before, from the other side, the address changes basically after every time a parent cursor is recreated. Okay. Also note a small restriction that in general, if you have obsolete cursor, these are the cursors that, as I said before, remain in memory after a new parent cursor was created, and this obsolete cursor cannot be displayed with tools like DBMS explain. And depending on the $V views, they are also not visible there, but then it depends on the view. There were also some bugs associated to them. Then as soon as a cursor was made obsolete, it would also not be shown by some views. So be careful when you have obsolete cursor; it might disappear kind of your view. Now, talking about limit and so on, you might ask why Oracle implemented it. What's the problem if you have many child cursor? And basically, to show that, what I wrote a number of years ago. It's the link you find here at the bottom. It was 2012. I just wrote a blog post to check what happens if a parent cursor has many child cursor, and what happens specifically to the performance of the parse. What you see in this chart is basically the blue kind of line or data points are associated to a setting where the threshold is set to 100. That means the maximum number of child is 100. Okay. And as you can see, if I create thousands of child cursor, then basically the performance is more or less stable. It's quick. You need in general less than 1 millisecond just to parse the test statement I used. If you want more detail, let's have a look to the blog post I mentioned at the bottom. From the other side, if the threshold is much higher, as you can see, basically the parse time increase linearly. And why it's that? Simply because before creating a new child cursor, Oracle has to check whether the already available cursor can be reused. Okay, so they have a structure which is basically a list of all child cursors, and you have to scan this list and check every one of them whether it can be reused or not based on your current environment. And as you can imagine, since it's a list, it's linear, there is no kind of index to access it or whatever. So the more child cursors you have, the more the parse will take. And the problem with that is, of course, that if this limit is higher and you have an application that executes a lot of parse and generates a lot of child cursor, you might experience also some performance problem, especially if you are in 12.2 or newer, because that's when Oracle increase this limit from 1,000 to 8,000. Okay, in general, if you have this kind of problem, what you will see are some weights related to mutexes, because if the parse is longer, the engine has to hold the mutex much longer, and so the contention can have more contention. Okay, so if you have this kind of situation in a recent database version, also as suggested by this most note, you might want to decrease the default, which is now 8,000. You might ask why it was set to 8,000. is simply because from 12.1 to 12.2, Oracle also increased the number of PDBs that a CDB can manage. Okay, and since the PDB in which you execute the statement is also part of the execution environment, because at the end in a CDB, in a multi-tenant environment, you have one shared library cache, so you really share also the cursor, and so at the end the con ID associated to the cursor is also part of the execution environment. And so since now we can have thousands of PDBs, they have to make sure that even though you have thousands of PDBs, you can execute the same query in every one of the PDBs. That's the reason why it was increased to 8,000. But of course, in many situations, either you do not have multi-tenant or you have much less PDBs. In general, I cannot remember that I saw a customer having more than few dozen, or let's say 100 PDBs in one CDB. Okay, and so maybe this limit doesn't apply in that case. Okay, so that's the limit for child cursor in a parent. Now, let's talk a little bit about bind variables, because as we have seen before, bind variables can be part of the SQL statement and are also important when we are talking about the environment. The optimizer or the SQL engine to decide whether, because it's not a decision of the optimizer, it's really the SQL engine, to decide whether it's possible to share a cursor, it also had to check the bind variables. Because you can, as you can imagine, you can have the same query that use one bind variable, but one application defines it as number, the other one as varchar. And in such a case, then the execution environment is different and cannot be shared. So bind variables has some impact on not only on the way you program or you write your code, but also a performance point of view impact on the database engine. And the performance impact can be good or bad. It really depends on the situation. Okay. The main advantage of using bind variables is that you can share more cursors. At the end, share the parent cursor. Okay, and so you avoid some parses because of that. That's the main reason why Oracle introduced the concept of shareable cursor to make them used as much as possible without having to create a new one. From the other side, the problem of bind variables is that they can hide stuff from the optimizer. Because of course, if the optimizer has a literal value, for the optimizer is much easier to generate a good plan because it knows exactly what the query or the SQL statement wants to do. If there is a bind variable, who knows? It might be different, okay, depending on the value which is provided. So bind variables introduce some advantages, but also some disadvantages. Now, as I mentioned before, the idea of bind variables in the sharing of the child cursor is related to the size and the type of the bind variable matters. Okay, so if you have again one bind which is number, the other is a varchar, you cannot share the same child cursor. You need two of them. And what is a bit maybe special is that also the size is important. This is probably because some memory has to be allocated upfront before executing, really associating a value to the bind variables, and for this reason, the structure must be set up for a specific size. But now, what you could imagine is that if the size is important, then for variables like types like varchar, if the application uses a varchar 2 or a varchar 3 or a varchar 4, I might need 3 different child cursor. And that could be too much, let's say, because it's probably not sensible to do. In some programming language like PL/SQL, there is no problem because usually you specify the maximum size once. But if you are in other programming language like Java or C#, you say string, and then depending how much data you put in there, it's bigger or smaller, okay? And that's the reason why Oracle introduced the concept of bind variable graduation. And the idea is that they don't use the size of the bind variable itself, but basically they parse the bind variable in 4 categories. So the engine says, okay, everything up to 32 bytes is the first group. From 33 bytes to 128 is a second group. 129 to 2000, it's a third group, and then what is more than 2000 is a fourth group. And so what will be important to know when the engine decides whether it can be shared or not is to know simply in which group I am. Also in this case, just to give you a better understanding, let's have a look to an example. So again, create a small table. In this case, even without data, it's not relevant. Initially, I checked the character set simply because, of course, the size of a bind variable is dependent of the character set. So if you have a database that uses this one, which is a single byte character set, it's completely different from having this one, which is a multi-byte character set. Because if you specify like do below varchar to 32, in one case is 32 bytes, in the other is twice as big. So it makes a difference in this case. But what I wanted to show you here is that I specify in my client, in this case is SQL+, 32 bytes, and then I execute 4 insert with different values. And what I will get is 1 child cursor, I am in $SQL, that was executed 3 times. No, it's 3 times, sorry, not 4. Okay. So in this case, all these insert statements were able to share the same parent and child cursor. Now, if I increase the size of the variable, initially I do an insert with 33 bytes, and the second execution is 128. What you will see is that now we get an additional child cursor to execution, because this is the child cursor associated with the first group. Okay, it cannot be shared because the variable is too large for this one, so Oracle creates a new one. If I use even larger variables, then what happens? A third child cursor, as expected. And of course, if I specify again even a larger variable, I will get a fourth child cursor. Now, what is important to see is that on the one hand, of course, they strongly reduce the number of child cursors by introducing this graduation. From the other side, here I have only one. Also, basically, this one is a number data type, so it doesn't change no matter what kind of number you're storing in there. But this one is the varchar. But now what you can imagine is I have 10 bind variables, and 10 bind variables having a varchar to a data type. You can easily start having also hundreds of different child cursors, because of course there might be many combinations between these 10 bind variables. And of course, 10 is not a very large number. So my point here is mainly that if you have a SQL statement with a lot of bind variables that are of a data type which is variable in size, it's quite easy to add dozens, if not hundreds, of child cursors associated with a specific parent, simply because the size of the variable it's different. Okay. If you wonder what's the flag associated with $SQL shared cursor in such a case, is this one which says bind length upgradable. No idea about the upgradable part, but that's how it's called. And again, if we decode the XML kind of structure, what you will see is Oracle tells you it's a bind mismatch. The bind at position 1, which is the second, because the first one is at position 0. And here you see the bind size. And what is important here, you do not see the bind size of the variable that was used at the moment of the parse, but the maximum size associated to it. Okay. To have more information about the bind variable associated to child cursor, what you can query is this one, $SQL bind metadata. Okay, and as you can see, you can get for every child cursor, okay, what is how many binds there are, in this case 2, right? What is the maximum length and what is the associated data type. So you could also, if you have a case with many child cursor, because of that you can also find out what's the issue or what how they are used. Okay, so that's about bind variable graduation. Now, this is what I already mentioned with SQL bind metadata. Now, talking about bind variable, it's also important to quickly talk about bind variable picking, because of course, as I mentioned before, for the optimizer, it's kind of a problem if the value of a bind is not known, because it cannot really produce the best execution plan for this particular value. And so what Oracle started doing already, again, more than a decade ago, is to pick the values of the bind variable. Just to look at the value of the bind variable before doing the parse, okay, and using that value during the parse. That is, on the one hand, is good because the optimizer can generate a better plan, okay. The problem with that approach is, however, that of course this value might not be good for every execution that will take place from the instance. Let's just have a look at an example of what could be the problem. So in this case, I create a table with 10,000 rows. I have a primary key on it, on the ID column. And basically the ID contains all the values going from 1 to 1,000, 10,000. It's just an integer value, which is, as you can see, generated with run here. So if I have a query like this one, where I will select most of the rows in the table, I have 10,000 rows, I select almost 99% of them. Okay, what you can imagine is that the optimizer decides to go for a full scan of the table. Okay, simply because I scan more or less, I need all the data in this table, so it makes sense to do a full scan of the table. From the other side, if I use a much smaller value, I need only few rows, then the optimizer will decide to go for an index. He says, okay, I just need about 41 rows. Okay, based on this estimation, so let's go with an index scan. That's good because, again, as I said before, if you have a literal, Oracle knows what the literal values is, knows the data in the database, if the stats are up to date, and can generate a good plan. Now, what happens if I use a bind variable? Initially, if I set the bind variable to a large number for this table, what you will see, since Oracle picks this value, is that the optimizer selects a full scan, and also the number of estimated rows depends on the variable that was picked. Okay, makes sense. Okay, but and in this case, the execution is good. The problem is that if the application decides to execute the same query but with a much smaller value, as we have seen before, Oracle should, as the optimizer should take an index scan, but in this case, since this query has a parent and a child cursor associated to it, and the child cursor can be shared, okay, Oracle decides to not create a new execution plan, but just to reuse the one that is available. And that means executing the query that requires an index scan with a full scan, which is, of course, not good. And that's the problem with bind variables. Okay, on the one hand, it provides more, with bind variable picking, sorry. On the one hand, they provide more information to the optimizer, but from the other side, they might lead to some suboptimal execution. Okay, and the execution then that is selected by the optimizer clearly depends on the value that was picked during the first execution. Okay, so depending on the situation, it might be good or might be bad. Okay, so be careful. Bind variable picking is introduce some advantages, but also some disadvantage. Let me also mention a limitation here. Bind variable picking doesn't take place if you execute a SQL statement through DBMS SQL. The package here is written in a way that doesn't support the feature and was written before bind variable picking was introduced. And after its introduction, since Oracle in the meantime also introduced native dynamic SQL, in PL SQL they decided to not modify the package. Right? So that's a well-known limitation. There is also a bug associated to it, but do not expect to see this bug fixed because it was created already a long time ago. But let's go back to the problem we just saw. If you have bind variable picking, it might be good for some execution, bad for others. And that's where Oracle decided to introduce another feature, which is called adaptive cursor sharing. And the idea of adaptive cursor sharing is to reduce the number of problems related also or generated because of picking. Okay, and the idea is basically, if you want to automatically recognize when a statement or a child cursor is reused, and this reutilization is not beneficial from a performance point of view. And when this situation is recognized, simply to create a new child cursor for it. That's the idea behind adaptive cursor share. Also in this case, I would say let's have a look to an example. It's basically kind of continuation from the one we have seen before. So I use the same table, the same test query, the same data and so on. So remember, large values, full scan is good. Small values, index scan is better. Now, let's use as before a bind variable, and this time we start with a small value. Since it's a small value, Oracle associates an index range scan to it. Fine. Now, if we specify a large value, since again, parent and child can be reused, it will be reused. So in this case, we just access, let's say, many data with an index range scan, which is basically not good. Okay. If we check the library cache, we see only one child cursor for both execution. Now, the point of adaptive cursor sharing is that if I re-execute a number of times the query and Oracle noticed that the execution are not performing well, okay, that means I execute several time query, for example, here that returns a lot of data, then what happens is that at some point Oracle will make the parent cursor and the child cursor that were available before, only the child cursor that was available before non-shareable, it create a new one. So here you see, I executed a query with a large number, I get a full scan, and if I execute now with a small number, I also get a good plan. What happened is really that, as you can see here, the old child cursor was set to unshareable, and at the same time, Oracle activated what they call bind awareness. And so they say, for this cursor, the value of the bind variable is important for the performance. So to perform well, I have to check, first of all, what is the value of the bind variable, and then to choose my child cursor depending on the value. as you can see, I have two different hash values. That means there are two different plans. This one is the full scan. This one will be the index scan. Okay. So at the end, with adaptive cursor sharing, Oracle tries to automatically detect this kind of situation and kind of fix them. Okay. As all automatic stuff, I mean, they can solve some problems, but can introduce new ones. So it's not a solution for all problems, but I would say bind picking without adaptive cursor sharing is in general not good. Both together can do a pretty good job in a lot of situations, but not always. Sometimes what we have to do is to simply to force the bind awareness by using the bind aware int. If you have specific SQL statement where you know that you cannot wait until the database engine automatically detects this kind of situation, you can put the int in the SQL statement and make sure that Oracle from the beginning use the bind variable value to select the child cursor. And if you have an application or part of it and that struggle with this feature and you cannot or you want not put the bind aware int everywhere, what you can also set is the optimizer adaptive cursor sharing undocumented parameter. You can do it at session or system level to false, and that again will force the bind awareness for every cursor. Of course, doing it as a system level, I have not seen somebody doing it. Be very careful, ask Oracle support and stuff like that. But at session level for very specific processing, it could be a way of working around a problem. Just few limitations about adaptive cursor sharing. Be very careful that if you have many binds, it doesn't work. What those many means, there are two kind of limits. There is an art limit at 14 binds, but for some queries also 8 is used. So I cannot be more precise, but 14 is in any case the current limit. Again, here I link to a MOS node that provides these limits. Be very careful that adaptive cursor sharing can only take place if also you have some parse calls. That means that if you have an application that parse once and execute many times, in that case, it's not possible. Adaptive cursor sharing cannot do its work because the cursor is open and yeah, it cannot be made unshareable. So be careful if you work with this kind of application. And it's also true for the PL/SQL engine. So PL/SQL engine tries to cache a lot of cursor, and if you have a cursor which is cached by the PL/SQL engine, and the SQL engine would like to invalidate it, it's not possible, so it won't kick in adaptive cursor sharing. Okay, and again, DBMS SQL, also in this case, it doesn't support adaptive cursor sharing. So like for picking, it was implemented before the introduction of this feature. So that was what I prepared for today. Just as a short summary about the session, I will say, if you want to share a parent cursor, the text of the SQL statement must match. That's the killer criteria. If you want to that Oracle shares a child cursor, then there are many criteria, but basically the execution environment must be compatible, and execution environment are not only initialization parameter, bind variables are important, NLS setting are important. Okay, everything must be exactly the same. Be careful, bind variables are in general good, especially in OLTP environment, they must be used. Okay, but they're not always good. So for example, if you are more in an analytical space and you have a query that goes through or access a lot of data, then probably not using bind variable might be better because it's better for the optimizer. Also, keeping the cursor open is in many situations what we advise to do, but there are again some situations where it might not be good. So be aware of this limitation as well. And finally, also remember that if SQL statement generates a lot of parse, you might end up with some contention. Okay. So, because in general, every parse could be an hard parse. So that's what I prepared for today. I don't know whether there are some questions. I see there are only 4 minutes left. So I guess if there are some questions, I will take them directly from the chat, or Gianni, you see something different?
They are into the Q&A window, if you can see it. There are 8 questions waiting.
Okay, but I can take 2 minutes, or it's better to
You can take 2 minutes, so you start with them and then you will switch to written
okay,
answers.
if there are SQL hash function to convert SQL text into, look for Tunnel Podder wrote some stuff to do it. I don't remember whether it is SQL or PL SQL or something else, but if you search for Tunnel Podder SQL ID generation in Google, you should be able to have it. How to force this? Sorry, scroll down. How to force SQL to use a particle execution? That's a long story here. I mean, not an easy one. Let's keep it, and maybe I will answer to it more in detail later on. Is to use ints as part of cursor. I mean, this one, in my opinion, you are talking about SQL statements, not cursor. Two different things. I would say I would not advise to put ints everywhere. Ints at the end are workarounds for specific problems. But if you have a problem and that's the only acceptable workaround, do it. But don't start putting ints everywhere. Okay, what do different number? Okay, what the number that are shown there means, honestly, I have no idea. Depending on the kind of mismatch or error, they put some numbers, but I never really read something about it, and I never spent time trying to understand what it means. I don't know whether it's simply related to the reason itself, kind of index of the reason. If you think optimizer mismatch is reason number 12, and another one is 13 and 14. But again, I never really looked at this number. When there are, the last question, when there are several parent cursors with the same SQL ID, yes, basically several of them can exist at the same time. As I mentioned before, some views doesn't show them, some views does, but you can, it's not a problem to create a test case that show you that you have 5 parent cursors with the same SQL ID in one instance, and all of them are used. So, because of course you have to imagine that Oracle tried to obsolete all the one, but if there is a cursor which is in use, it cannot be simply removed from the library cache. This is how to find how much time is being spent finding the appropriate shot. Okay, so the question is how to find out how much time is spent finding the appropriate child cursor. Honestly, I have not taken this parse. I just, I think we are talking about the chart where I show that. In my case, I simply used the whole parse time. And the idea was that the query I executed was something like select star from dual. So I expect that the parse time itself is really short, and all the difference you saw on the chart was because of the child management, not because of the parse itself. But of course, with some micro profiling in the kernel or kernel, you might be able to find this kind of information.
Okay, so now we are over time, so you can answer the next question in written form if you can.
Yes, I will do it immediately. So thank you very much for everyone that attended it. I hope you found some good information. And of course, you can always get in touch with me if you have additional questions.